viewers, you are welcome once again to our channel. My name is Ayoluwa. If you are just joining us, we said this class is dedicated to learners. It's dedicated to you if you are watching us and find it difficult to understand physics. So this class is actually for you. Alright, so in the last class we looked at fundamental and derived units, and today we'll be looking at dimension of physical quantities. Don't forget, I said, for you to make this class meaningful, you need to get your writing materials, you need to get your pen, your booklet, a jotter, anything, your readiness, and also your listening here. Alright, let's go quickly. Dimension of physical quantities. Now, you shouldn't forget, from our previous class, fundamental and fundamental units, I need you to understand that the three basic quantities in physics are the length, the quantity of length, the quantity of mass, and the quantity of time. Those three quantities are the basic quantities in physics. Okay, how can we define the dimension of a physical quantity? In simple terms, the dimension of a physical quantity is the way it is related to the quantities of length, mass, and time. I take it again. The dimension of a physical quantity is the way it is related to the quantities of mass, length, and time. So mass, for example, now the quantity mass, the unit is in kilogram. We said that in our previous class, and the dimension is m. The quantity length has a unit meter, and the dimension is l. The time, the quantity time has a unit seconds, and the dimension is t. So now, if I pick, for example, a physical quantity like velocity, how am I going to define the dimension of velocity? The dimension of velocity as a physical quantity is the way it is related, to the quantities of mass, length, and time. Dimension analysis of some of these physical quantities. Alright, let's take a look at some of these examples. We have deduced the dimension of area, volume, of velocity, of acceleration, of force, and so solution. We should deduce the dimension of area. So number one, we want to find the dimension of area. Don't forget from also previous topic, area is your length times your what? Your breadth. Your length times breadth. So now the dimension of area will now be equal to what? The dimension of length times the dimension of breadth. Now, from the previous table, we have the dimension of L. L is measured in meter. So in other words, the dimension of length is L. The dimension of breadth is also L. It's also measured in meter. So we are having times L. In other words, the dimension of area is equals to L times L, which is equals to L raised to power 2. That's the dimension of area. The second example, that of volume. The dimension of volume will be, the formula for volume is your length times breadth times what? Times height, right? Alright, so the what do you call it? The dimension of volume will be equal to the dimension of your length, that's L, times the dimension of your breadth, that's also L, times the dimension of your height, which is also L. So we are having the dimension of volume to the what? L raised to power 3. Let's go to the next one. Velocity. The dimension of velocity. What is the formula for velocity? Don't forget, velocity is equals to what? Displacement over time. Right? So the dimension of our velocity will be equals to what? The dimension of displacement. You know, displacement is relating to distance. So that is, the unit is in meter, and which makes the dimension is L. So L over time. The dimension of time is T. In other words, the dimension of velocity is L per T. L per T. Do you get that? Alright, so the fourth one is acceleration. The formula for acceleration is change in velocity over time. So in other words, the dimension of acceleration will be equals to the dimension of our velocity, which we are gotten from the, that's changing, that's L per T over the dimension of time again, which is T. From your law of indices, you know this is going to become L T raised to power minus 2. Let's look at the dimension of force also. Force, the formula for force is your mass times acceleration, mass times acceleration. So the dimension of force will be equals to what? The dimension of mass. Our mass is kilogram. So the dimension is m. You know, times what's the dimension of acceleration? We just did it not quite long. That's acceleration is equals to change in velocity over time, right? And your change in velocity, we have LT minus 1 over T. So acceleration is LT raised to power minus 2. So LT raised to power minus 2. In other words, the dimension of force is MLT raised to power minus 2. Alright, so if you have any question, please feel free to message me on my WhatsApp number. I'll be leaving you to do that of prayer on your own. So I believe you have also learned today. You have learned something. Please don't forget to like, don't forget to comment, don't forget to subscribe. Thank you very much. God bless you.